In example 1, we're talking about a man who's 5 feet 9 inches tall who casts a shadow that's 8 feet 6 inches. Assuming that the man is standing perpendicular to the ground, what is the angle of elevation from the end of the shadow to the top of the man's head to the nearest tenth of a degree? So as soon as I know I'm trying to find the angle of elevation, I know that I have a man that's perpendicular to the ground, that means I'm going to be doing right triangle trig because I'm trying to find an angle and I'm going to have a right triangle. So basically I'm going to draw out the picture. So I have a man who's standing perpendicular to the ground, and his shadow, so this is his shadow here, um, is 8 feet 6 inches long. So what I'm going to do is I'm going to switch this over to the same units. So it's probably easier to convert everything into inches. So to go from 8 feet, I'm just going to multiply 8 by 12. And when I do that, I'll get 96. So 96 for the 8 feet plus the 6 inches means his shadow is 102 inches. So I'm going to go ahead and label that. And then I also have 5 feet 9 inches for his height. So if I convert the 5, so I'm going to just do 5 times 12 to get 60. So 60 inches plus the 9 inches means his height 69 inches. So I'm going to label that. And since it's talking about the angle of elevation from the end of the shadow, so here's the end of the shadow to the top of his head, I'm talking about this angle right here. So this is the angle I'm trying to find. That's going to be my x. So we also know that we have a right angle, so basically we have this right triangle. So we're going to decide if we're going to use so, ka, or toa here. So just like always, you want to look at your angle, go opposite that, label that the opposite. Hypotenuse is across from the right angle. Adjacent is just next to the angle. So it doesn't look like I'll be using the hypotenuse, so I'm going to use tangent because it's the only one without the h in it. So it's going to be tan of the angle, which is x, equals the opposite, 69, over the adjacent, 102. And I need to solve for x. So in order to solve for x, in this case, remember you can't just divide by tan because it's tan of x. So to undo the tan, you're going to take the tan inverse of both sides. So you'll have x equals, it'll be tan inverse of 69 over 102. So you're going to enter that in your calculator, making sure your calculator is in degree mode, and you're rounding to the nearest tenth. So nearest tenth will give me 34.1 degrees for the angle of elevation. So I should say angle of elevation, make sure you actually answer the question, equals 34.1 degrees. So then this next example here is a little bit more complex. So it's talking about a lighthouse that's 460 feet above sea level. So this height right here is going to be 460 feet. And the angle of depression to a boat is, so boat A is 42 degrees. So that means the angle of depression, remember you always measure from the horizontal line. So we're measuring from this horizon or the horizontal line, and we're measuring downward. So this angle right here to see boat A is 42. And then you want to look for those Z shapes. So the Z shape occurs right here, so that means this is also 42 because those are alternate interior angles, and they're congruent because these lines, the angle of elevation, the angle of depression, are created by parallel lines. So these horizontal lines are parallel, which is why those angles are equal. Then we look at sometime later the boat has moved closer to the shore, which is boat B, and the angle of depression is 50. So going back up to the horizontal line, we always measure from the horizontal line, down to the boat is 50. So that whole thing is 50 degrees. So that means the little section here would be 50 minus 42. But really we don't care about that because we're looking for those alternate interior angles. And when you look For the Z shape, you see right here that this angle would also be 50 degrees. So remember, it's because we have this horizontal line that we're looking at to create a right triangle. So here's your right triangles. So we want to know how far to the nearest foot has the boat moved in that time. So that means I really need to know this distance right here. That's what I'm trying to find. So the question is going to become, how are we going to find that distance? So in a problem like this, you always want to look for two triangles, because remember that right triangle trig only works on right triangles. So I can't just use this triangle right here, this obtuse triangle, because it doesn't have a right angle. So what I have to do is I have to find two right triangles, and basically look for ones that overlap here. So in this case, I have this right triangle, the smaller right triangle, and that'll allow me to find this side x. And then I have the large right triangle with the 42 degrees, the 90, and what that'll do is allow me to find this whole thing, which will be y. And then once I know x and I know y, I'll do y minus x, and that'll give me this right here, which is what I'm trying to find. So in the end, we're looking to find the difference between these. So this is what I'm looking for right here. So I'm going to set up my two situations here because I have the green right triangle. So I'm going to start with that. So to solve for x, I'm going to look at, okay, the opposite will be this, going across from that angle. And then this is going to be the adjacent because the hypotenuse is up here. So I know I'm going to be using tan. So if you think SOHCAHTOA, you're using the O and the A, so tan. So it'll be tan of 50 equals opposite, which is 460 over the adjacent, which is x. And in this case, you're going to put this over 1, cross multiply. So we get x times tan of 50 equals 460. And we're trying to get x by itself, so divide both sides by tan of 50. Those cancel here. So we get x equals 385.9858303. And I'm going to leave that exact answer because I don't want to round too soon. So then the next step, so there's the little piece. The next step is going to be to find the side y. So for step 2 here, I'm going to be using tangent again because I have the opposite, and then this is the adjacent, this side here. So I'm going to do tan of 42 because that's the angle of the large right triangle, equals opposite 460 over adjacent, which is y. And then from there, cross multiply. Equals 460. Divide both sides by tan of 42. Make sure that when you divide, you're dividing by this in parentheses. So you get y equals 510.8817568. And then from there, you need to subtract these two to find the distance between the two boats. So distance between boats will be y, which is 510. So 510, and remember you're using this exact answer, keeping all the decimals. You don't want to round too soon. So really I'm using that exact number from the calculator, minus 385.9858303. And the distance that you get between the two boats is 124.8959265. And the question asked us to round to the nearest foot, so nearest whole number, and our units are going to be in feet, so it'll be round up to 125 feet is the distance between the two boats. And then the last example here is looking at another situation where you have multiple triangles being used. So as soon as you see a picture like this, you should be thinking multiple triangles are being used. to set up the situation. So we have, in this case, the two people that are standing here are 27 feet apart. So I know this distance that we just found in the last problem we're actually given in this problem. And Jeff, who is the furthest away, sees the top of the building at a 33-degree angle. So this drawing isn't perfect. Really, it should be from his eyes is where this 33-degree angle is. But we're going to use the drawing that's given. So I'm going to actually label this 33 degrees, even though it's not really from his eyes. And then Jessica sees it. So this angle to the top of the building is going to be 42 degrees. Remember, when you're talking about angles of elevation and depression, you're always measuring from the horizontal line. So elevation, you're measuring from the horizontal line below. Depression, you're moving from the horizontal line above. So then from here, we're trying to find what is the height of the building. So this is what I'm trying to find. I'll call this X. This is my end goal here. So hopefully you see the two right triangles. Remember, we can't use this obtuse triangle here, even though we know the bottom of it's 27 and we know 33. We can't use that because it's not a right triangle. You always have to use the right triangle. So in this case, I have the same two right triangles. I have this smaller right triangle, and then we have the larger right triangle where this green one's in. So we have this larger right triangle with the 33-degree angle. So what we need to do is we want to find the X. Now, the problem with this example is we don't have as much information as the last one, because instead of giving us the height here that we could use in both equations when we set them up, we're trying to find that height. And if you look at the green triangle, all I know about the green triangle is the angle. So really, this side here in the green triangle, I'm going to have to call y because I don't know it. And that means when I'm looking at the pink triangle here, the entire base of it is going to be 27 plus y, because I don't know this piece and I know that this section is 27. So when we go to set this up, it's going to be similar where we're going to have our two proportions like we did in the last example. So we're looking at, okay, this side's going to be the opposite. These sides are going to be the adjacent. So if I'm looking at my green triangle, it's going to be tan of 42, because it's opposite and adjacent again, equals opposite over adjacent. So I can't really solve this because it's two variables right now. So what I'm thinking is we're going to have to do a system. So as soon as I see two variables and I can't solve for either one of them, it means I have to have a second equation. I'm going to have to do a system of equations, going back to algebra. So then for the second equation here, I'm going to use the second triangle. So this is going to be the adjacent. So what's going to happen is it's going to be tan of 33 equals the opposite x over the adjacent. So this adjacent is 27 plus y. So really this 27 doesn't really help us too much, other than it helps us know that it's going to be 27 plus whatever the length of the green triangle's adjacent is. That's all it really tells us. So now I have my two equations, and what I need to do is I need to solve them for one variable and then plug in to get the other. Now, it would make sense to solve for x, to do this so that we eliminate all the y's so that we can just solve for x. The problem with that is the algebra will get more complicated. So what I'm going to do is I'm going to actually get, and so that I can solve for y, and then we'll just, once we get y, we'll plug in to find x. So what I'm going to do here is I'm going to basically get x by itself, which is pretty easy because I'm just going to cross multiply. So y times tan of 42 is equal to x. And then right here, instead of having x in this equation, I'm going to replace it. So this is going to become tan of 33 equals, so like I said, instead of x, I'm going to make it y times tan of 42. And then it's all over 27 plus y. And then from here, we're going to work with this equation now. Now that it's only in terms of y, so that the only variable is y, I can solve it for y. So I'm going to go ahead and I'm going to cross multiply. This needs to go in parentheses, so it's going to end up being tan of 33 times 27 plus y equals y times tan of 42. So what we're going to do now is we're going to distribute this tan of 33, because remember, tan of 33 is just a number. So I'm going to keep this as 27 times tan of 33. I'm not going to actually put it in the calculator because I don't want to have to write the whole decimal. Plus y times tan of 33, when you distribute, equals y times tan of 42. If it confuses you leaving it in terms of tan, go ahead and get decimals if that will help you solve it. But I just don't want to have to rewrite everything. So then what I need to do is group my like terms. So this is just some number times y, and this is some number times y. So that means those are like terms. So I'm actually going to subtract tan 33 from tan of 42, and that'll be left, that's what my coefficient of y will be. So those will cancel, so I'll have 27 tan 33. And then in your calculator, what you would want to do is you would want to do, so pretend this said 3y minus 2y. You would do 3 minus 2, you get 1, and you would tell me 1y. Same thing, these are your coefficients. So you're going to do tan of 42 degrees minus tan of 33. And when you do that, you're going to get 0.2509964511. And then you just keep the y. So you basically just pretend like this said 5y minus 3y. 5 minus 3 gives me 2, and then you write the y. So all I did was subtract tan of 42 minus tan of 33. And then from there, you're just going to divide both sides by this decimal here to get y by itself. And when you do that, just put this in parentheses, divide by this decimal. So these cancel, and you end up with y equals 69.85758141. So now what I'm going to do is I'm going to take this equation, or this answer, and I'm going to plug it back into that first equation. So this is going to come back into this equation right here, because in this equation, I already have x by itself. So what I'm going to do is I'm going to take x, and I'll find it by plugging y in. So it's going to, instead of y, I'm going to plug in what we just got for y, which was 69.85758141, times that by tan of 42. So we get for x 62.900048883. So that means the height of the building to the nearest foot will be 63 feet. It'll round up.